Sorry that my recordings haven't been working out lately. My laptop has been having some sort of infection or whatever, and I'm hoping that it will start to work now. So in 6.6 it says, and I'll just read it in case you don't have the book with you. It says, write a 2D info interface for 2D geometric shapes. It says the interface permits the computation of perimeter, area, circumference is perimeter, but we can call it perimeter if we want. For a circle, people don't call it perimeter, they call it circumference, but that's okay. We can, for the sake of polymorphism, give it the same name and call it perimeter. And then it says here it has area and a center and a width and a height. So these are properties which all of the shapes apparently have in common. It says implement this interface for a rectangle, a circle, and a square. The constructors for these shapes will be used to specify the parameters. Well, what does that mean? Well, a circle must have a radius, so if that's true, the parameter will have to be the place where the radius goes. And that parameter must be passed in as the constructor, which means that you will not be able to change the radius after you've constructed the circle instance, right? Because according to this, the parameters are set with the constructor only. Then it says here, the constructors for these shapes will be used to specify their parameters. Below is a sample interface to get you started. That's below means here it is, I already typed it in, but if you want the benefit, you have to type it in. So then I felt that because I was creating an example in an extra help session, I would type it in. So I'm going through the process of doing the homework. You see? So I'm doing my homework. So here is the beginning. It says shape 2D info get area. That was the first thing I did, was I created a specification for how you get the area of a shape. Do I know what the shape is? No. Do I care? No. Do I know who will build the shape? No. Do I care? No. The only thing I care about is that it meets the specification, which means that if everybody in this class has a different shape that they have to implement, and it doesn't matter if it's a circle or a square or a rectangle or a triangle or a rhomboid or a dodecahedron, droidloid, oid, they're all going to be able to pass back area, because every shape must have an area. So at the end of the day, I also give you something called point. And the point has some private double x and y, and it is too constructed with the parameters specifying the location of the point. And that point is a data structure which neatly contains the x and y coordinates. I then proceeded to do the following. I said this dot x equals x. Now, I'm not sure that we ever discussed the this statement, but this refers to an instance of the object. So it says the point under constructions, x, will be set equal to the value of the x quantity which is being passed in as a parameter. So this refers to self, or an instance of the class itself. Then comes the set location. And set location also works like a constructor in that it allows you to set the parameters in the point. Get x and get y, these are the accessors which let you get the individual components of the point, x and y. And clearly, if I wanted to do this in 3 or more dimensions, I would just need to add more variables. So then I create this interesting little ditty, which I call my test framework. And in the test framework, I create the point is at the origin, 0, 0. I want the point to be shared by all the shapes, because I really don't care where they are. I create the square and the circle and the rectangle. And the square and the circle and the rectangle are a little bit different from one another. When you pass in a number like 10 for the square, what that means is that the height and the width are the same, and so it will copy them. When you pass in the origin, that means the square's center is at location 0, 0, the origin. Similarly, if you use the circle and you say 10, what that is referring to is not the width and height, but instead the radius, because circles normally are specified with radius. So in that context, the circle uses the same exact number, 10, but interprets it differently. Similarly, P, which is the location of the center of the circle, is at the origin 0, 0. Then comes the rectangle, and look at that. It has a different number of parameters. It has width and height, and they're not the same. They're 5 and 10. And it has a parameter for the point for the origin, and that could easily have been somewhere not 0, 0, but I didn't care, so I left it at 0, 0. Then comes the interesting bit. I want to create an array. Now, an array is generally speaking going to be a list of homogeneous data types. But in this particular case, the homogeneity corresponds only to the interface shape 2D info. And since they are all of type shape 2D info, you do not need to cast to the interface that they implement. Now examine the power of polymorphism. Ooh, right? The power of polymorphism says we can write a for loop that says no matter what the shape is, we can treat it the same. Many shapes, right? It's not that many, it's only 3, but enough to be many. Many shapes all being treated the same. They all know how to get their area. They all know how to get the perimeter. And later, if we want to, we can add a new method and make it so that they can all move. So now it turns out that when you go through and compute the area for a square, maybe it's 10 times 10, and that's 100. But if I compute the area for a circle, well, it's pi r squared, so that's 100 times pi, which is 314.59, whatever. So then it says if I want to do the area for a rectangle, well, that's just width times height. So that's like 50. So we're going to get really different numbers from these really different shapes, but we're all treating them the same. We just say get area. Similarly, to get the perimeter, well, in a circle, we will call it circumference, and it would probably be something like pi times 2 times r. And then for square, it is perhaps 4 times the width, and for the rectangle, it's 2 times the width plus height. So when I go to implement the rectangle, I can see the area is width times height. The perimeter is 2 times the width plus height. When I implement the square, I can see that the area is width times width, and the perimeter is 4 times the width. And when I want to implement the circle, I see that it's pi r squared, or the perimeter, which is also called the circumference, is 2 pi r. So now I have 3 different shapes with 3 completely different implementations of the same interface. And this is the essence of polymorphism. What it means is if I have a team of all of my graduate students, you all in the back should be sitting in the front. Why don't you come up here in the front? It's much less crowded up here in the front. You don't have to sit in each other's laps back there. So I'm thinking that what we'll do is we'll take away the chairs from the back row from now on, so no one can sit back there. We'll put them in the hall, and that way people will insist on going to the... Yeah, come. Yeah, move. This is, it's silly to be all the way back there. It doesn't help your grade any, and it certainly doesn't help your vision. I can't even see you back there. How can you see me? All right, well, if you're going to sit back there, I guess I can't help it. So this is, yeah, move. Yeah, come forward. Come. Thank you. You make me think that I don't shower or something. So there's this idea here that we should be able to outsource to the team. And we use our interface in order to do it. But watch what happens to errors when you decide that you want to add something to the interface. Now it says here my interface should be able to get the width and get the height. And I didn't do that. Oh no, I forgot. So let's do that. Public double get width, public double get height. Oh, I've created errors. What do I do? Well, as it happens, if you click on the red and then you see the little hourglass, the light bulb, the red light bulb, if you click on it, it says something. It should say something. Implement methods. Aha! And so he says get width, get height. This is great. So I say, okay. And what does he do? He writes it for me. And so what I return is the width. And over here what I return is the height. But he says, wait, there's still errors. And of course the reason why is because I didn't meet the specification on my other shapes, like the square. So now with the square, if I implement the methods, I guess I return width, and for height I return width again, because the height and the width are the same. Similarly for the circle, how do I know the width and the height? Well, I guess the width is 2 times r, right? Yeah. It's a diameter. So it's diameter in both directions. So I return r times 2, right? R times 2. And similarly here I return r times 2. And that's it. I'm there. Then he says here I need the center, right? And the center returns a point. Well, that's convenient because I've created a point for each of these things. So now if I said to you, well, let's see if we can get the center, public point get center, and now he gives me 3 more errors, but that is okay. Return P. And there you have it. Whoops. Did I make a mistake? Oh, the point is called C for the center. I don't know why I called it C, but it doesn't matter because at the end get center will be the same for all of them. So then, in fact, if you wanted to, you could make it so that it's the same for all of them. You could say Shift F6 and you could change it so it's point P, enter, and that will change everything except for this parameter here, which you can change to P. Enter. And so that's that. That's how you do that. Now the next part of this is 6.4. Using the answer to exercise 3, add a move method that will alter the location of the shapes. Notice how the move method is the same for each shape. What does the move method do? It says set P, right? So if the move method is set P and you want a move method available, why not write an abstract method which implements the Shape2D info interface? ABSTRACT class movable, and what it does is it provides a implementation for the Shape2D info interface, but because it's abstract, that should not be an error. And so what that tells me is I can provide extra classes and extra methods that'll do movement. So let's see, public void move. It gives me a new point, P, and it says this dot P, let's see, oh, I know, get center. Do it this way. Equals P. So then you say to yourself, well, geez, that's weird. Why is this red? No one knows? Yeah, we haven't defined P yet, so we have to create the field. And now if I go in here under rectangle, instead of implementing Shape2D info, I can extend movable. Or I could provide an implementation for Shape2D info and extend movable, but I don't need to do both. So I'll just do extends movable. It'll still be subjected to polymorphism, but even better, we can now share the code for doing the move. So now everything is movable. Let's see if this runs. So we should see 3 different areas and 3 different perimeters. And sure enough, we do. All right, so the first area is, this must be the square, right? I forget. Yeah, so it's square, circle, rectangle. So the square should give me an area of 100. The circle should be 314.59, and the rectangle,
third one is rectangle.
Rectangle is square. Get area. Oh, you know what? I'm interleaving area and then perimeter for each one of the shapes. I should probably have shapes with a name. Every shape should have a name. That's a very good idea. How could I get the name? Well, I can print the name. Let's see now. System. Shapes of I dot get class dot get name. So if I get the name of every class, what does that buy me? I'm thinking there's probably a nicer way to do that. Yeah, so it's a square, and he gives me the area and the perimeter. That doesn't seem right. Is that really the perimeter of a square? 40? Oh, right, because it's the width times 4. Yes. It is correct. So what did I do in order to get the name of the shape? Well, I went into the reference data type, and I went to get its class. And this was the class from which the shape was constructed. And it was called the Book Examples Chapter 6 Reference Data Types dot square. So that is what's called a fully qualified class name, including the package name that appeared before it. We could have made that a little nicer. We could have made it so that every class has a name, right? And if we did that, we could have just said, set name, and made that part of shape 2D info. But instead I just went in and used the class, which enabled me to get the name of the class. It's kind of an advanced thing, but it's interesting that you can do that. Then we got the circles area, and then the rectangles area. And the power of polymorphism is that you could keep adding shapes all day long and treat them all the same. And someone then asked me, okay, how do I draw the shapes? And then I said, for that, we need the chapter on graphics, which is not on the midterm. You'll be happy to know. I don't know if I mentioned it to you, but next week we have a midterm. And the midterm will be taken here in this classroom using our laptops. And so everyone must bring a laptop. Does anybody have a problem with that? Really? No problems? Okay, great. That's great. This will be my very first time using Blackboard to administer a midterm. What could possibly go wrong? Right? It's got to work. People do these things, or so I'm told. What will be on this midterm? Well, let's have a look. Very glad you asked me this question. Let's have a look. Chapter 1, 2, 3, 4, 5, 6, 7. There was a homework 7, which was administered like a practice quiz, although it only counted as much as a homework. Now, I checked at 2 o'clock in the morning, and nobody was writing me, "Oh, professor, I'm having network issues." So I assume that everybody was able to submit the homework okay? Yes, it worked? Nobody had a network problem? Thank God. Okay, that's good. I'm very happy to hear that. Were there some tricky questions on homework 7 that you had troubles with? There were. Okay, so we can cover some of those. Page 83. I did homework numbers 1 through 9, and then to make it work out so that it adds up to 100 points, I added a 10th question, but that wasn't a hard one, I hope. So then it was a free 10 points for you. Free 10 points. So I'm going to go through each one of these in turn, and you should tell me if you had some troubles, okay? 7.1, find the error. Anybody have any troubles with that? Find the error in the following code. Class, customer, abstract print, abstract class. Find the error. The constructor is missing. The class cannot be abstract. A, B, C, D. What could the answer be, I wonder? Abstract print. Oh, it looks like it's missing a semicolon. Yeah, that's not correct. It says here, public abstract class customer. That doesn't sound like an error per se. The print, that looks all right. So yeah, the print, right. What's wrong with print? Why is print? Why is B the correct answer here? No return type. Oh, no return type. What about the idea that you should have an abstract class, an abstract method with a body, a method body?
Yes.
Is that permitted?
No.
It is not. So suppose I said to you, here is my abstract class, and it has a name, public void abstract get name. So that's legit. Why is he giving me a hard time? Maybe because abstract has to come before void. Yeah. So that works out. You can have an abstract method get name has the same exact impact as having get name in the interface. It becomes a requirement of any class that extends the abstract class or implements the that extends the abstract class. But what if you did something like this? Oh, that's an error. Why? Because you defined a method body. So the first rule of abstract methods is abstract methods have no method body. Right?
Yes.
Yes. Now, suppose you said, oh, yeah, you can't have a method body. Does it have to return something? Yeah, sounds like it does. But there are certain methods that don't return anything. What do we call those methods? A method that returns nothing, not even void, is
Constructor.
a constructor. Thank you. Thank you. So movable. So now I have an abstract constructor. Oh, but wait. Does that make sense? How can I have an abstract constructor? Ah, you can't have that, right? So now I put this in, and it says, but wait, how can you have a constructor that's not abstract without a method body? I say, okay, then I'll put this in. So now I've got a constructor. How can this constructor possibly work? I've got a constructor, but it's an abstract class. Can you actually invoke this constructor? Yes, you can, but only from a subclass. So subclasses during their constructor can call super dot, and it will construct the superclass. So if you are making a new instance of the movable, and you say sout, control J, enter, and go movable here, when will movable, the constructor, be invoked? Well, it looks to me like you have certain things which are movable, and they have constructors. will they invoke the superclass's constructor automatically? And the answer is no. But if you invoke super within the subclass's constructor, then the superclass's constructor should be invoked. And actually here, it is being invoked. So the constructor is being invoked. Can I invoke it again? I think so. Suppose I said super like this. Now he's saying super must be the first statement in the constructor. Okay. So we'll make it the first statement. That's all right. So that means we're constructing the superclass first. Now what happens? Great. So now you're invoking the superclass, and when you click on super, what happens? He calls movable. So that means I can pass a variable in as a parameter to the constructor for the superclass. How cool is that, right? Because now I can pass in the point of interest, point P. And now, as part of the constructor, I can say this dot P equals P. And that's sweet, because if this is no longer private but instead protected, that means subclasses will have access to it. That's because of the accessor modifier, which we learned about in Chapter 7. So now, and this is the really cool part, I no longer need a separate point in rectangle, because instead, when the point is passed in, I call super a P, and it gets stored in movable. And now I don't have to go this dot P equals P anymore. Similarly, when super of P is called, this point P is now refactored, so it is contained in the movable superclass. How cool is that? So now we can all share the same variable name in the abstract superclass movable, super of P. And so now I can get rid of this point here, and I don't need to call this dot P. And if I'm right, I also got rid of it. Oh no, I forgot to get rid of it here. And now, every one of these methods supports the movable invocation, which means I can proceed to move each one of them. And we can test that hypothesis. Because as we go through our list of shapes, we can call move. And we can move it to P. So then the question is, how come that didn't work? Because Shapes 2D info isn't the same as movable, because Shapes 2D info doesn't have a move method. Now you have two choices. The first choice is either change Shape 2D info into movable, or the second choice, which is make Shape 2D info so that it includes a move method. And there's nothing wrong with that. So we'll create the method move, and it returns void. And now it looks like I'm getting an error. Maybe it should be public, huh? Still getting an error. Can't resolve. Oh, right, because the move method doesn't get printed. right? It returns void. Right? Move. You don't print a move. What else is wrong with all of this? Implement methods. Because his subclass is movable, he should have a move method. Oh, it's move with a lowercase m. That's it. I had a typo. Silly me. So now I can proceed to move the shapes anywhere I like. Maybe I should run this. How's that for polymorphism? It's getting involved, right? It's interesting. Because now it turns out I can get the class, I can get the area, I can get the perimeter, I can use the movable superclass to reuse certain code and implement certain parts of the specification in a shape 2D info. And this gives me a lot of flexibility in how I write the code and how I allocate the writing of the code. So now if I have as many shapes as there are people in this classroom, we can all proceed to implement those shapes individually. Sweet, right? What else? 7.2. You can never instance a final class with a single private constructor. That was true or false?
False.
False, okay. Why is that?
We can instances it.
You can instance it if it's a singleton.
Yes.
Yeah, because singletons always use final constructors and final private constructors and final classes. They instance themselves. You can never subclass a final class. Is that true?
Yes.
Why?
The final class, it should be final with
Yeah, final means you can't subclass it, because that by definition.
by definition.
Okay. You can initialize a final method member.
True.
Yeah, you can initialize it. You just can't change it. It is an error to instance a final class.
No.
No, it's not error, because that's what singleton does. It's an error to have an abstract method in a non-abstract class.
True.
It's an error to have an abstract method in a non-abstract class. Yeah, that's true. Abstract methods can have no implementations. We just saw that's why that's true. Abstract classes can be instanced. That's false. Make use of the singleton pattern to make sure that there's exactly one instance of a payroll class. Guess that's true. Was that the question?
It's like program.
Or was that maybe that? I think the way it was written, the intention was you would write some code, but the way I asked it, it became true false. I must have changed it. Yeah. So I'm not sure what we said for 7.9, but I don't think this was exactly. What was 7.10? I don't remember. But no one has a question about it, so I guess it didn't bother you. Say it again?
Final classes cannot be instanced.
Oh.
That was asking it two ways.
Yeah, it's the same question asking.
Yeah. was asking two ways.
Yeah. Okay, so then we went through all of these. Are there any questions about 7? Okay. So then, do you have any questions about prior homeworks or the midterm? I'm very happy to go over any material that you would like. No questions, really? Everyone is, I mean, this is this is your time. You get to bring whatever question you like, and I would try to address it. So, hey, come on in. So then the other thing I would like to do is I'd like to introduce you to the basic ideas of Chapter 8. And Chapter 8 is about arrays. And so we've already seen a little bit about arrays, but not a lot. We saw the array being used for storing the shape 2D info. Right? So here is an array, shape 2D info, right? Let me ask you a question. Does it matter where the square brackets are? Can I put them here? Would that be okay? No? I think I'm going to try anyway. Well, Java likes it. Do you think maybe it doesn't work, though?
Important security message. Please call the phone number provided as soon as possible. Guided through the removal of the adware, spyware, and virus on your computer. Seeing these pop-ups means that you have a virus installed on your computer.
If I have to come over there, someone is going to get their comeuppance. So this is working, I think. So this idea here that you have to put the square brackets somewhere specific doesn't seem to have good foundation. You can put them wherever you like. Suppose I said to you, I'm enjoying my shapes very much. They're great. Shapes are just great. But I would like to make a lot of them. Maybe I don't know how many. I want thousands, tens of thousands of shapes, millions and millions of shapes. And maybe circles will be used for planets and squares will be used for stars. And rectangles will be used for bracketing large galaxies. So there's a lot of these things. An astronomical number, in fact. So how many shapes will there be? And the answer is, I do not know. So then I say to you, can I use the shapes array? What if I want the shapes array to be bigger? What can I do? Use a vector. Oh, okay. So now I have my shapes vector. Vector shapes. I don't use a bracket anymore because it's not an array. And now I have to say equals new vector. So now I switch to vector. And he says to me, geez, multiple choices, Alt-Enter. So I scratch my head and I hit Alt-Enter because he told me to. And now he gives me this pop-up and he says, which vector do you want? And the answer is, I want the java.util.vector, which is part of the basic Java distribution. So I scroll down there and I hit Enter, and IntelliJ imports it for me. But there's a problem, because I get the length of an array using array shapes.length. How do I get the array? How do I get the length of the vector?
We don't know the length. Length is variable.
Length is not a variable in vector, no. I do size.
Size.
So now there's a special method involved with the container class vector, which allows me to get the number of elements in the vector. And wait, it says here there's an error because shapes of I is not working because it's not an array. So how do I get an element at a specific location, I?
Size.
Well, the answer is, if you want an element at a specific location, it will come back as an object, O, and it will equal shapes dot element at I. And now if you think that object is of shape 2D info type, then you can say shape 2D info S equals shape 2D info of O. And maybe you should use something else, call it shape. There. So now this is a shape that was grabbed from the vector at location I, and I can use it for all of these interesting and wonderful invocations. Oh, and the move as well. Notice not a single shape was changed. Right? None of the code for implementing any of the array area computations or the perimeter computations or the movement computations, none of that was changed. The only thing I changed here was the container used for the shapes. Moreover, I can have as many elements in the vector as I like. But because I refactored the code to change it from array to vector, I'm not going to add any more features. I just wanted to fix it, and now I have to test it. Because whenever you refactor the code, you want to check to make sure the functionality is the same. So when you run the test, you get the same errors, the same answers. And guess what? It doesn't work. How come? Right? Well, I'm going to run it for you, and it says done. Didn't print anything. Oh no! You've broken it, Professor Lyon. Quick! Change it back. No, I didn't break it. We're in process of fixing. Okay. Yes, so what do I do? What should I do? I have to remove all the system stuff? That's a good idea, but I'm not doing that because that's wrong. Instead, what I'll do is I'll add the shapes individually to the vector. So I have to say shapes dot add element S, which adds the square. Shapes dot add element C. Shapes dot add element R. Now we've put the shapes in the container. Now we can go back to the container and take out one element at a time and print it and do our computations. And now everything is working as it did before. Now, let me ask you a question. Since a vector is nothing more than a collection of java.lang.object, is there any limit to what type of reference you can put into a vector? Can I add anything I want to a vector? Can I add an int to a vector? I can? Oh, great. Shapes dot add element 10. Huh. Is that really what did I just add 10? I think you must have automatically promoted it to a reference data type because you know what comes back out is not going to be an int. It's going to be an object. So it's going to have wrappered it automatically for me using the integer class. What if you said int? Whoops. He still gets it. Wow. It's like magic. He does that for you. So now what happens if you run your code? It's going to be very happy, right? Because it's going to take 10 and convert it into a two-dimensional shape, and then he's going to compute its area and its perimeter. How's that going to work for you? Not so good, right? What kind of error do you think you're going to get if that happens? here comes the number 10. And you said to the compiler, trust me, I'm going to convert this to shape 2D. And the compiler says, wait, this is an integer. It doesn't know how to compute its area. It doesn't know how to compute its perimeter. It doesn't know how to move. It doesn't know anything. It's a number. Right? So what will happen? Well, you'll go through this and it'll start to work. And then when it comes back out as an object, it'll say, aha, here comes a class cast procedure. And it says take the object, java.lang.object, and convert it into shape2d info. And the runtime will try and do this. And it will say class cast exception at runtime. And it will throw the error with a line number and tell you exactly what it is you did and where exactly in your code you did it. Because you said this was a shape2d info. But at runtime, it discovered that whatever it is you put in this collection of objects was not a shape2d info. So it ran up to a point and then said class cast exception at runtime at line 58. And sure enough, if you click on it and look, it says, hey, wait a minute, this object is an int. And ints are not shapes. Therefore, you got an error. And rightfully so. Right? You made the rule. And the rule is this is a collection of shape2d infos. So if you don't like the rule, you can't be too upset about it because that's your rule. You have to change the rule. Don't put, stuff that you don't want in there. Now, one thing you could do is you could guard the input to the vector, right? Well, how would you do that? Well, the way you would do it is you would create your own collections class, right? And your collections class could be defined in a very simple way. Class shapes. And the shapes class has a vector. Vector v equals new vector. And now if you wanted to, you could even make this private. That's using a the principle of least privilege. No one should ever need this vector. If they want to add elements to your shapes class, they can call one of the methods that you provide. So for example, maybe you want to say public void add shape. And what gets passed in is a shape 2D info. S. Now when you add the element, vector v.add element, you can add the shape and you will know that nobody is going to be able to gain access to your vector without going through your add shape, which means that you have made the shape's contents type safe. It also means that you have guarded the input by using your own shape2d interface as a data type to make sure that everything will be of that type. So that's great. I love it. So now suppose you said to me, I like vectors, they're nice, but I really want to get all of the things that are in the vector back as an array. Well, at any given time, we know how many elements are in the vector. It's v.size. And if you want to get the shapes, public, I guess it's going to return an array, shape2d info, array, get shapes. Now that's fair. Now how am I going to get all the shapes out of this vector into one array? Well, the first thing I'll need, I think, is an array. Let's call it shape2d info. And that array will have a size, s array, and it will be equal to new shape2d info, and its size will be v.size. Now all that does is it allocates a series of references of shape2d info type, where the entire array will be a homogeneous array of shapes, and you will be able to go through those shapes just like you go through any array using array.length. But now you have to go from the vector into the array before you return the array to the caller in order to get the list of shapes. So what you do is you say v.copyInto s, and that is a very efficient system-oriented mechanism. You could use a for loop for this, but instead I use copyInto, and now I can return s. And so now you can add all of your shapes into the shapes class instance that you have handy. That's your little database of shapes. And then you can add as many as you want, and when you want to get an array of shapes coming back out, all you have to do is call getShapes. And it will take all those array elements and make an instance of an array of reference type, and it will copy the references in. You're not making new instances of shapes here. You're just moving references around. It's a 32-bit machine. These are 32-bit addresses, and the addresses are just being moved. So it's still very efficient. And so now I can go through my shapes class, and I say to you, gee, it's a very interesting thing, but the shapes class could in fact be an aggregate example of the interface shape2dinfo. It could get the area, aggregate area of all the shapes. It could get the aggregate perimeter of all the perimeters. It could even try and average the center and give me an aggregate center, an average center. Maybe it could even give me, by going through each one of the shapes, the minimum or the maximum width or the maximum height. I guess you'd have to add all the widths and heights. I'm not sure how you would do that. It might not have good meaning. We could certainly move all the shapes together as a single entity. So that's kind of neat. So here's my vector shapes, and I want to change that from a vector to something of type shapes. So why don't I do that? Here's shapes. S shapes equals new shapes. Okay. And now I can go into shapes, and instead of add element, I have to add something else. It says add shape. Oh, that's all right. And now I know these are all shapes. That's pretty cool. And now if you wanted to, you could get an array of shapes, actually an array of shape2dinfo, s-array, equals shapes dot get shapes. So that's pretty cool, because now we can go back to sa.length, and now I can say sa of I. But look, sa of I is always going to be shape2dinfo type. So I can go right up in here and say sa of I. Eliminate this whole elements at stuff and check it out. How elegant is that? Now when you run it, and you have to run it because you've got to test code every time you refactor like this, you should be able to see the same results. And you do. So that's slick. Now suppose you said to me, I'm liking the way this is working. I've got my little, I'll say, protected data structure. I created an abstract data type. Suppose I said to you, what will happen if I go into the shapes and I want to add a shape and I want to add 10? He says, no way. You can't do that. Which means you have avoided the class cast at runtime error that you saw before. You've traded a runtime error for a compile time error. That's a very good trade, because now what it's saying to you is, I'm sorry, but 10 is not a valid quantity to store in a list of shapes. And that goes for customers and payroll and laptops and whatever other thing you have instanced of. That doesn't go in there, because it's not of a shape2dinfo type. You've guarded the input to your abstract data type. That's so important, because you don't want those kinds of runtime errors. So now you've seen vectors, you've seen arrays, you've seen how to convert from vectors into arrays. Is it possible to convert from an array into a vector? Well, someone said no. But I think the answer is not no. I think the answer is the exact opposite of no, which is also called yes. So let's try that, just for a good time. Suppose I said to you shapes can be created with a constructor, which has the same name as the class and returns nothing, not even void. That's legitimate. But I could try and create the shapes from another kind of constructor. Let's create the shapes from an array of shape2d info type. SA for shapes array. Now I'll make this public, and I have overloaded the constructor for shapes. There are now two ways to create shapes, and one way is to start with an array and internally create a vector, and then later you can add shapes to make the array effectively longer, and then turn around and convert it all back to an array by calling getShapes. That's cool, right? Well, let's see now. SA, that's an array. I can iterate through every element in the array. I can use a for loop for that, right? So let's make a for loop. For integer I equals 0, while I is less than SA.length, LENGTH, I plus plus, and now I can go this. I can say v.add element SA of I. Bang, I'm done. Someone said it couldn't be done, but I did it in 2 lines of code, no less. So now, as it turns out, if I wanted to, I could make it a little array of shape2d info. How fun is that? Shape2d info, SA, shape array, equals, and then in parentheses, P, comma, S, comma, C, comma, P. Oh, I don't think you can put in P. I think P is just a point. How about this? Let's move this underneath the rectangle so I can have access to my rectangle. There we go. So I got SCR. So I'll do a new array. S, comma, C, comma, R, comma, C, comma, R, comma, S. So there's my little array. Oops. And now what I'll do is when I make my new shapes, I'll write SA. So now it'll have SCR, CRS, and then I'll do add shape SC and R. So we'll have a grand total of 1, 2, 3, 4, 5, 6, 7, 8, 9 shapes. And then when we're done and we call S shapes, we need a new name here. Let's call it SA2. And now, I think maybe we're ready to try it. So, can you convert from an array into a vector? Yes. Can you convert from a vector into an array?
It's a conditional, but when vector is of some finite length, we can convert vector to an array, but when vector consists of some infinity elements.
You mean there's a case where you might not be able to?
Yeah.
I agree with that. So if a vector is consisting of a series of reference data types, can I convert that into an array? Even an array of object? How about an array of reference data types? And doesn't a vector always consist of an array of reference data types? Internally, right? Every element in a vector must be of reference data type. So I know how big the vector is because v.size. And I know I can make an array of object, which is the primordial java.lang.object reference data type. So I can always convert a vector into an array. Always. Always. I think so. Unless you can think of a way to avoid my always statement, it is generally true and correct. So what do you think of that? Now we did the vector can be converted into an array. We got the array can be converted into a vector. The vector can have an arbitrary length. You can just keep adding shapes as long as you like. I think we've got this nailed, unless you guys have questions. Vectors. Hey, should I find out what else we talked about in this book? There's probably other stuff in here, right? On vectors and arrays. Okay, I talk a little bit about abstract data types like a queue and a list and a stack. So let's assume that the table represents the abstract data type, and I want to push my marker onto the stack. So now my marker is contained on top of the table. Now I'm going to push my next marker onto the stack. There we go. This is going to be a disaster. Okay, so now, yeah, last in, first out. That's right. And now if I want to, I can add another marker onto the stack. This one doesn't actually stack. So now the thing that you get when you pop off the stack is the thing on the top. Right? That's typical. And then if you want to pop again, the next one comes off. And when you want to pop again, the next one comes off. That's a stack. Right? So now let's assume that you wanted to create a stack using a vector. Right? Well, we can make a new class called shapes, but we don't have to. We've got one already. If you wanted to, instead of add shape, you could call this push shape. But I would rather not rename everything. Let's do the following. Public void push shape 2D info S. Now, how would you add the element if you put it on the bottom, right, by using add element? Add element goes like this. Puts it here, the next one comes in, the next one comes in. So if I do this, v dot add element, that's not exactly putting it on the top, is it? V dot add element. But now, if you wanted to, you could make it so that it corresponds to an implementation of pop. Public shape 2D info pop. Now, how do you pop it off the stack? If the last in is the first out, what you do is you want v dot element at v dot size minus 1. And that is what you return after you cast it. Return into shape 2D info. And so that'll grab it right off of the top, but is it actually going to remove it? No, it won't. So if it doesn't remove it, what will it be doing with it? What can I do to remove an element at a location? Well, it looks like I can remove an element at a location and return an object. So it'll be the element at that location. So if I said remove, I now have a means of removing an element from the stack. And I took it right off the bottom of the vector, but that was the last one in. So it should be the first one out. That begs the question. If that's a stack, then what's a queue? First in, first out. So now if this goes in, and then this goes in, and then this goes in, and you want to dequeue, then this is the one that's been waiting the longest, so it comes out. So a queue is just like the line that you wait on. And when you go to wait on the queue, you expect that if you've been there first, you would be the first one served. That's called a single server, single queue discipline, which in queuing theory is supplemented by multi-server single queue or multi-queue multi-server. Can you think of an example where there's a single queue and multiple servers? How about the bank? Every teller is a server, but there is only one queue. So that's single queue, multiple servers. Can you think of an example where there are multiple servers and multiple queues? Well, how about the supermarket? Everybody who ever went shopping had to go wait online and look at the other line that moved faster because you were on the wrong line. I'm always on the wrong line. It looks like the short line. They have very little groceries, and then what happens? They take out the check, and they start chit-chatting about the coupon. And they start saying this, that, and the other thing about how they didn't get the right price. And they're like, oh, we need a price check. And then somebody, very slothful, will go somewhere else in the supermarket, and they will say, oh, no, it really is 2 for 1, and you're not allowed to get anything. And then there's just more arguing. Right? And I'm sitting there going, come on, it's only 25 cents. What are you arguing for? So this is, right, multiple server, multiple queue. You've all had what I would call high standard deviation on waiting time. The standard deviation on waiting time I equate to what I call aggravation factor, right? So aggravation factor, that's when you say, well, my expected waiting time is low, but this time I waited very long. Then you get very aggravated. So putting all of that aside, now if we want to come up with our new queuing discipline for single queue, single server, we want to have, someone said first in, first out, but other people might say FIFO. And for last in, first out, they might say LIFO, yes. So if you wanted to do the same exact thing with a queue, you could write public void enqueue, ENQUEUE, and then we'll put in a shape 2D info, v dot add element s. And now when you dequeue, I don't have to copy that because most of it will be retyped. Public shape 2D info dequeue So now it's v, oh, I know, we have to cast. So return, R-E-T-U-R-N, Jesus, it must be getting late. Shape 2D info. Return shape 2D info is being, it's being, whatever it is we're returning, we're casting to type shape 2D info. V.element, it's remove. Now, what are you removing? It's the one that's been waiting the longest. So is it at the bottom? No, that was the one you added in last. The one that came first was at the top. So now I have to go back to the top. So there'll always be a 0. And every, whatever the number of lengths, with shape 2D info, the vector will handle it for us. How's that? That's cool, right? So that's a lot. I mean, that's kind of interesting. We've got NQs, DQs, push, pop, stacks, Qs. It's all very, I learned a lot here. Wow. What else did we learn? Stack, Q, got a shopping cart, page 101. What else? Oh, what do you suppose would happen if there was no elements left on the vector and you just DQ'd? What if you said pop and there was nothing to pop? What if you said DQ and there was nothing to DQ? Would it be a compile time error or a runtime error? Runtime error, because compiler has no idea when you're going to call pop or when you're going to call DQ. In fact, you will get something like internally, the vector is using an array. So internally, the vector is allocated the array and keeping track in the index number of where the top is and where the bottom is. So you will get an array index exception at runtime if you try and pop when you're not allowed. That's legitimate. Now you could try and catch that exception. You could try and prevent it. Maybe you could print something that says, oh, you're going to run out of space. But the exception that gets thrown essentially says the same thing, so there's no point to it. So we saw the use of the copy into method. Right? The copy into method required that a vector be copied into an array and that the vector have a size which is equal to the array length. If that doesn't happen, if they're not the same size, you're going to have an error at runtime. It'll be something like an array index out of bound exception at runtime. We did trying to think if there's anything else in here that you guys need for the midterm. On the midterm, I plan on doing a little bit of radix conversion. You guys remember radix conversion? You don't need to review radix conversion, do you? No? You don't want me to torture you with that? So decimal to binary, decimal to octal, decimal to hexadecimal, binary to octal, binary to hexadecimal, basic numbering conversions, that'll be on the test. Let's see what else. Singleton pattern will be on the test, so I will ask a question or two about that. Final modifiers, abstract modifiers, and static modifiers for methods and variables. That'll be on the test. The instance of keyword, right? I don't know how much we covered on that. I think we did a little bit. Instance of, that'll be on the test. So what I've done in creating this Blackboard test is I've made it so that it presents the questions in random order and the answers in random order. And when you go through the test, you have to answer one question at a time, and then when you go from one question to the next question, it doesn't necessarily do the same thing for you that it will do for your neighbor. So you're sitting next to one another, but looking at each other's laptops will not do you any good. I think I should add to that, I hope. But I would prefer it if you looked at your own laptops during the test. I'm not going to try and be the copy police, but I will be walking around, and I may ask you to get up and move if people are just too close to one another. So if you can, when you sit, spread out a little bit, use the front row. We should actually have chairs on the front row. I don't know why they're all clustered. Oh, I know why, because I wanted this chair. So, in theory, we should have enough room in this class. So if we can try and spread out a little bit when you come in, that would be great. I'm probably going to give you until, I would say, 4 o'clock. It's not a very long test, and so we'll plan to end early, but if some people go over, I won't be overly strict with it, but I'd like it to be done by 4. And then probably you'll see questions that you'll think are trivial and other questions that you think are hard, and I would say don't rush. There's no penalty for getting things wrong, but it doesn't help you if you get a bunch of them wrong, right? It's like I don't count it. Let's say I don't take away points if you get it wrong, but you don't get any points if you get it wrong. Put it that way. So let's see if we can do something fun with arrays. Fun with arrays. That's not fun. Let's try something else. Maybe it'll be fun. Amazed. Something here should work. I don't know why that didn't work. Oh, yeah. So here's an array. If you think about it, the array consists of octothorpes and little points. And inside of the octothorpe point array, there is an S for start, and an E for end. And the goal of the program is not only to generate the array, but also to solve the array through a principle we call search, which is considered a class of algorithms for finding solutions. And so here is a poor solution. Looks like it goes the wrong way and then backs up and then eventually finds its way up to escape and then hugs the wall and then finds the out, and there's the out, and that's the exit. So that's a solution to the maze problem. How would you solve a problem like this? How would you implement? First, how would you store? Right? How would you store the maze? How do you think that gets done? Say it again.
Just dimensionalize array.
It's an array. An array of what? What is it? An array of char, right? This is a two-dimensional array of char. That's fair. Two-dimensional array of char. One char represents the boundary or the wall, and the other char represents the space. That's the period. And then there are these special characters, symbols for start and end. How would you solve such an array? Right? You got to find your way out of the maze, assuming there is a solution. Well, one way in which you can find a solution to a maze is using what's called the gallery method, which is to hold one hand against the wall and just hug the wall and keep going, and eventually you should find an exit. So this is that solution. It holds its hand against the wall, finds it bumps into the wall, bumps into another wall, backtracks, bumps in, backtracks, keeps hugging the right-hand corner, keeps hugging and hugging until finally it reaches the exit. Now suppose the exit were over here. Well, it would take much longer to find the exit. It would hug around in here, backtrack, hug around over in here, go all the way up, backtrack, hug around down in here. Eventually, I think it would find its way. Wait, maybe there is no way. If you put the exit right here, there's no solution because there's no hole in this wall. It's isolated. Oh no, it isn't. Eventually it would find its way in through here. I think so. We could try it. Let's put E over here and make this a space. So here is how I stored the maze as a string, and then what I'll do is I'll take that string and I'll convert it into a two-dimensional array. So this is an array of string. Let's see what happens if you run it. Yeah, takes a while, but it eventually finds its way. So it leaves a little trail of breadcrumbs as it climbs up the wall, goes around, goes down and through here, goes down and through here, backtracks, goes up and through here, goes up through here, goes down through here, backtracks, up, around, backtracks, up, down, backtracks, up, looks like it goes up, and then eventually finds its way. So it takes a little while. It's not a very efficient algorithm, but it is eventually going to find an answer. That's kind of neat. So there's that thing that they call a string. What kind of data type is a string? It's a reference data type. Yeah? And in fact, the array is also a reference data type. I don't know if we've talked about these things, but strings are sort of important. Let's see if we can do a little thing about strings. So this is a test of split, and what we'll do is we'll call s.split on the string, and we'll put in the comma. And what we expect it to do is take comma-separated values and make an array of string. SA is the string array. And then when I call printutils.print, I expect that as a loop, in a for loop that goes through every element in the array and just prints it for me. So I expect this is a test of split to be printed vertically, which is just what you'd expect. So if you said to me, I'll put a semicolon in here instead, that won't get split. So it should say something like this is, or this semicolon is, and then it'll say a test of split vertically. So that might be very handy for people who are interested in doing stuff with comma-separated values. Where would I get comma-separated values? No ideas? What if I went to Apple, right? And I wanted to find the historical prices for Apple. Well, I could get those prices and download them as comma-separated values. Download to spreadsheet. So here are these values. Right? These are comma-separated values. Right? Let's take a few. I'll copy them. And then I think instead of doing file I/O, I'll turn them into literals inside of my little CSV parser. So I'll make a new Java class, and I'll call it CSV parser. And what I'll do is I'll start off with these interesting looking values. String array equals, and we'll just put that in a semicolon, and then put in a quote. Now what happens if I type in paste? Ah, very interesting. He's got new lines, and he's got commas, and he puts it into a string array. That's pretty cool. So I'd like to be able to do something with that. Let's make it static and create a main method. These are stock market prices, you know. So we have a publicly traded bourse called the New York Stock Exchange, and what it has is symbols which typically have 3 characters. And we have another publicly traded bourse called NASDAQ, and it contains symbols of typically 4 characters. So when you see a symbol like AAPL for Apple Computer, it has 4 characters. That must be NASDAQ. NASDAQ is typical for publicly traded companies that are considered high tech. They often go to NASDAQ. Although sometimes they switch back and forth. Red Hat went from RHAT on NASDAQ to RHT on NYNEX, New York Stock Exchange. Don't know why they did that. I think they didn't like the way NASDAQ was treating them. Something like this. The choice of exchange is a very personal one for a company, but you usually find out what it is in a public way. So then if I went through this with a little processor, what could I do? Well, there seems to be something going on here with this very interesting looking character \n. What does that stand for? New line. New line. And someone said something about splitting. Is this an array? Kind of doesn't look like an array, does it? It looks like one big string. That's what it looks like to me. Yeah, that's what it is, one big string. So if I want an array out of this, how could I make an array? What could I do? Well, I probably want to split it based on the lines, right? So if each line goes into a separate element, then as I go from one array element to the next, then I'll be going from one line to the next. That sounds reasonable, right? What's your idea? You tell me. So if that's the case, then maybe what I could do is I could say something like s.split, and now let's split it based on a single character \n. You think that's permitted? No, he doesn't like that. How about if I split it based on a string? So I'll promote my character to string type. And that he likes. Okay, so now I want to print it. So I write a little loop for integer I equals 0, while I is less than sa.length, I++, n paren, and then s out, control J, enter, sa of I. So let's see if we can parse this string so that each one of the rows goes into a separate array element. I think that would be swell. And that seems to work reasonably well. All right, so comma-separated values are still there. There are these commas. But each one of the numbers has some kind of a semantic meaning. And the semantic meaning is given in the header. So if I wanted to create some sort of a data structure that represents the semantic meaning for a stock quote, this is what I would do. I start by saying Let's make a class. And I guess it's called end of day quote. But perhaps we could just call it quote. And the quote consists of a series of numbers with special representations. We could probably make a claim that this doesn't look really like a number and would take some sort of heroic effort to parse it. So why don't we store it as a string, just for now. So there'll be the date, for the open, it looks like we need a float. Probably for the high and the low and the close as well. I like to use lowercase for my variables and uppercase for my, how you say, classes, right? Uppercase for classes, lowercase for variables. So why is there an the adjusted close? That has to be like this. I think I need a semicolon here. There you go. Volume is always an integer. In fact, I think it could be a long. The open, low, high, and close, and adjusted close, they could all be floats because there's dollars and cents. All right? So how do you think I would make the constructor for the quote? Well, we know we're going to get a string with an array, right? So why not do something like this? Quote string Q, and now we're going to have a little string array of our own for the quote. String SA equals Q dot split on quote comma end quote parentheses sem. Okay. So now what I got, and this is kind of neat, is I got the order in which the data will appear. That's part of like this header over here that they gave me at the top. So what I can do is I can make a little comment to remind me where things go. So now I can say, well, SA of 0, that's going to be the first thing, that'll be the date. And that's going to be a string, so I can say SA of 0 is equal to date. Date equals SA of 0. And that's fair. And the next thing up is the open. Well, the open is equal to a float, but I have a problem. SA of 1, that's a string. An open is a float. How do I convert from string to float? What should I do? Go like this? Float? And then you like it? Oh, he's not happy with that. He says it's inconvertible. Inconvertible. Cannot cast string to float. That does not work for me. But I liked your idea. I was even hoping it would work. But it doesn't work. What can I do? You do realize I can't hire you as Java programmers unless you can answer this question. If you don't know the answer to this question, you're not a Java programmer. So the answer is, you use the wrapper class float, and you say parse string. Does that work? I don't think that works. No. No, sorry. Doesn't work. Any other ideas? How about this? String dot float? No, won't give me that. Oh well, I guess it's impossible. What do you do when you don't know how to do something? Really? Well, don't you guys know how to Google things? How do I convert string to float in Java? Enter. It says float.parseFloat. How's that? So if you don't know the answer, you can always Google it. Float.parseFloat. And then SA of I. So he's not happy with that either. And doesn't he say it was going to work? Float.parseFloat? Something's wrong. What could possibly be wrong here? There has to be a way to do this, right? Oh, you've got the wrong... Is this the wrong float? Oh, this is the float interface. Oh man, that sucks. That's the wrong float. No wonder I was having so much troubles with it. You need the java.util.float. I forgot where float lives. Oh, maybe it's java.lang.float. How does one get the caps lock off? There it is. Ha! You see why there was a problem here? I had my own version of float. That was no good. I needed the java.lang.float. So then I said parse the float, and now I got my open. Thank goodness. Presumably I can do the same thing for the high. And that would be number 2. And now I can do the same thing for the low. And that would be number 3. And now I can do the same thing for the close And that would be number 4. And for the volume, what do I do for volume? Any ideas? Well, it's supposed to be a string that represents a long. So how about if we went into java.lang.long and looked for parse long. What comes after that? Adjusted close. Adjusted close is supposed to be a float. So I'll borrow this and make it element number 6. And that's the adjusted close. There. How's that? So now all the type conversions are done. So now I can say something like this. Quote Q equals new quote of SA of I. Probably don't want this last one because it doesn't have enough elements. And now for a quote, I think maybe you should probably have a string representation. Public string to string, return the date plus quote, colon, end quote, and maybe we'll return the close. Because that's all we care about. Don't care about the open and the other stuff. So now with a toString override, I should be able to print out the relevant passage. Let's see if that works for us. So now we've learned about strings, string manipulations, wrapper classes, and means by which we can convert numeric strings into primitive data types. Except I got an error. Whatever it was we passed in was not a proper string. So we can certainly print it out and see what's coming in. Let's print out SA of 1 and see what it looks like. Maybe my split didn't work properly. If there's a space. Oh, you know what? I'm trying to parse the first line. And you can't convert these into numbers because those are letters and they don't have any numeric representation. So this part right in here is not legitimate end-of-day quotes, but the rest of it should be. And there it is. That's pretty slick. So here's the date, and this is supposed to be the close, as opposed to the adjusted close, which happen to be the same thing. And here's the date and the close, date and close, date and close, date and close, date and close. So it works. Comma separated values being converted into Well, stock quotes. It's all very exciting. Now you can do computations with these things. For example, you could go to the quote and you could say something like date and close, and maybe you could put in plus quote, and maybe the difference between the date and close, or the delta. Maybe a little space in there would help. So the delta equals plus q dot get open, or perhaps q dot open, minus q dot close. And you can see that the plus and the minus is confusing the overloaded operator, which is designed to concatenate strings when used in this context. So you have to put it in parentheses in order to tell it to do the evaluation of the subtraction first, then take the number and concatenate it as a string to the prior delta equals. Because when you have quotes like this, the order of precedence for the plus operator is going from left to right. And so what he's trying to do is concatenate the first quantity as a string, and then he sees the subtraction, and he doesn't know what to do. So you want to make sure subtraction is done before the plus sign is used to concatenate the strings. So now I should be able to see the deltas every day. And here the delta is negative, negative, negative. Here it's positive, and then positive. So it's kind of a little random walk in terms of stock price. What do you think of that? Real market data, as you can see. Easily available to you. Isn't that fun? Very fun. Some people might call this financial data mining. They might do that. The comma-separated value, being able to manipulate it and put it into your code, do it in an automatic fashion. This is very common. People do this all the time. They get it from Excel. They get it from Quicken. They get it from Intuit. They get it from all the different mathematical applications. Everybody saves in comma-separated value. Okay, I don't know why, but it's common. It's I'll call it de facto industry standard. So that's a common sort of thing to want to do. This business about parse float. What do you suppose would happen if something like a little space were added to parse float? Do you think it would be tolerant of a space? I mean, that doesn't seem like such a big deal to me. You think this could work? It should work, right? Well, guess what? Doesn't work. It's an arithmetic exception at runtime in the parser, and it says, "Ew, you've got a space." Oh, wait, it liked it. Oh, I'm wrong. What if I put a space in the front over here? Will it like that too? I'm going to torture this. Let's try it. I didn't think it would work. It didn't used to work. I think Java just got better. So is it going to accept the plus sign? And the extra zero? You know what? I think maybe it's going to like it. If it likes the trailing space, it must like the leading space. It gives you the same answer. Let's torture it some more. Let's put in a 0 in here. I guess it should like that because that's part of a number, right? Why not? I mean, if you say, what if you said, please enter in a float, and you typed in bleh. Well, then the computer should say bleh, right? Because how could it parse that? Can't parse that. That's garbage. Yeah, good. Okay, thank God. So you have to guard the inputs or try and catch the number format exception at runtime. Because if you ask the user to type in a number and the user goes bleh, then the computer is going to go bleh, and that's it. And your program dies. So it's not that tolerant of random input. Nor should it be. And if you put a comma in here, I feel sure that will not parse. Because the parser couldn't be that smart. Because well, not only that, even if it were that smart, really, what should it be doing if it sees illegal input? That's a big question. Now, somebody might like to use commas instead of decimal points. You could check that. There might be a British way to express large numbers that include commas. Actually, do they do it with commas or decimal points? They just so in Britain, maybe this is my. I mean, I've seen somebody say if you want a million, it's 1, 0, 0, 0, 0, 0, 0. Now that's like, I don't know, something Americans do, I think, right? That's not international. 10,000, right? They don't do that in other countries, do they? But in some countries, if you want 10,000, they write it like this, right? But then how do they write $10,000.20? Do they write that too? I don't really know. How does that work? Somebody probably knows this, but they're not saying. And the way I'm used to it, if it's $10,000.20, I write it like this. That's normal, right? Do you do that also? That's the British way? Okay. So I think that we don't have a problem then. But then what do I do to parse a long that has commas in it? Right? I mean, suppose somebody says, how many dollars do you want to spend? And they write 10, 0, 0. How do I convert that into an int or a float? I don't think parse float is going to like me, right? If I write, here's the main, okay? Just for humor me for a second. String, I don't know, money. Here's some money. And the money is equal to, make up a number, $10,000. Okay. Now I want this to be converted into double, float, something. So let's try float. Float f equals. How do I get my money? It's not $10. And I can't use comma separated values here. I have to say something like float. I know. Java.lang.float .parse int, parse float, and I put in this money. Can that work? I don't think that can work. Right? Because how does parse float know the comma is supposed to be just a simple separator? I can't know. Yeah, sure, it doesn't know that. But that's a legitimate way for me to express a quantity. So if I see commas, I have to replace them. So what can I do? Dot replace comma with nothing. So if I replace comma with nothing, then I should be okay. But I have to be quite explicit about it. You know that it's not going to do it for you. So at the top, I expect it to print 10,000. And certainly it did. So that's legit. So if you're trying to do money, like real money, wouldn't this be like 20? $10,000.20? That's a legitimate number, right? Even with the comma. But Java doesn't know this. So if you're parsing money, I mean, somebody might put in the symbol for euros. That would really mess it up. So you'd have to look for that character and change it out. And then maybe you'd have to convert it to the currency that's local. So that's a little bit of a string manipulation lesson, but I think we needed it because it's important. We're dealing with strings all the time, and that's basic data processing. When we look at something like that, I think we need to think about what is a practical way to handle the language so that it can deal with some of our routine data processing tasks. All right, any other questions for the midterm? You've seen string reference data types, float reference data types, parsing from strings into floats. You've seen comma-separated values and splitting into arrays. You've seen constructing abstract data types like stacks and queues. You've seen how to guard the input with vectors. How to convert from vector to array, and how to convert from array to vector. These are all topics in Chapter 8, you know. What do you think? Guys are all good with this? No questions? All right, well, I'm going to let you go early. If you have no more questions, it sounds like you're all set. Have a good evening. Thank you.